Okay, question number 44. A spaceship leaves Earth and travels at a speed of 0.60 relative to the Earth point. Okay, so you are measuring the speed with relative to the Earth. So your lap frame is Earth. Therefore, this is your velocity given. So this is the Earth. The spaceship goes like this, goes to a point P, returns back. P is 3 light years from the Earth. P is 3 light years from the Earth. Okay, distance is here. Spaceship then returns to Earth. Ignore the time taken to reverse the direction. So there's double engine at gas. Okay, so it comes back like this. Returns back to Earth. It is the total distance traveled is 3 light years forward, 3 light years backwards. The total distance is 6 light years. Okay, what is 1 light year? The distance traveled by the light in 1 year, which can be written as 6 years multiplied by the value of c. Okay, what is the time taken for the total journey to and from P as measured by observer in the spaceship? Okay, he is asking you the dilated time. How do you calculate? If S is given to you, then we also need to find out what is the speed here. What is the speed over here? So we will find out the speed. The speed is given to you as v over here. S by v will give you the time taken by the spaceship to start from the Earth, move to the point P and return back as calculated by the stationary observer on Earth. So therefore, I write this as S by v, which is 6 light years divided by 0.6c, which is 0.6c here. 6c, cc goes away here. 6 by 0.6 will be 10 years. So a person, a stationary observer on the Earth, will measure the time taken by the spacecraft to start from the Earth, go to point P and return back to be equal to 10 years. Now, if that is the case, what will be the time taken by the time taken as measured from the person in the spacecraft? Will be more than 10 years or less than 10 years? It will be less than 10 years, right? So therefore, what should I do now? I should now write T is equal to the as measured over here. T should now be equal to T, so root of 1 minus v square multiplied by 10 multiplied by 10 is what I need to write. It should now be equal to square root of 1 minus, what is v here? V is 0.6c, it is 0.36c, c square divided by c square multiplied by 10 should now be equal to this c square, and this c square goes away. So 1 minus 0.36 should be 0.64. 0.64 root is 0.8. So 0.8 multiplied by 10 should be equal to this. So answer should be 8. Now what did I do? What is the secret here? So many times when students start working on the relativity related problems, they get confused by this equation writing whether I should write T equal to T naught into gamma or T naught by gamma. What is T? It's always a confusion for people. But I don't do like this. So what I do is I consider the proper time to be as measured by a frame which is at rest. I have already taken this to be the Earth one. Then the moving frame to be considered to be the dilated frame. So therefore, I consider dilated frame, and I knew that whenever I consider dilated frame, the time taken should be lesser than what I observed. So therefore, I put this root of 1 minus v square by square, then numerator instead of v square. There's a lot of confusion here. People consider this to be here and T naught is substitute 10 here. When you do this, you get the answer 12.5. This completely wrong. Okay, therefore, 8 is correct.